I would like to introduce our BCI EEG device, Imagine and Paint, a brain-computer interface for creating digital artwork. Our device is designed to help people with injuries or mental illness that prevents them from being able to paint or draw effectively. For example, amputee patients, people with arthritis, or Parkinson's disease. In order to use our device, the user must be able to open and close their eyes, as well as imagine motor movements in the hands and legs. This device is for users who wish to creatively express themselves but can't physically. With this, they can create simple artwork without the need for a mouse, pen, or touchpad. Our physical device takes after the traditional design of a helmet for balance. The majority is made of tempered foam with areas made of rubber encircling locations for electrode placement. Clips are located near each hole that holds the electrode cable in place. It also comes with an adjustable Velcro chin strap to hold the helmet in place. Our application that accompanies our device has two modes, color mode and paint mode. Color mode allows the user to select one of 8 colors, while paint mode enables the user to paint and draw on a blank canvas.
The application is based around these two modes with the option to swap between them whenever the user desires to do so. Upon startup, the device begins in color mode. If the user wishes to select a color, they must focus on said color. While they do so, a gray flash highlights each color one by one for 1 second each. When said flash occurs on their focused color, it acts as an oddball stimulus and triggers P300 signals to prompt the system to select said color. Afterwards, they can swap to paint mode by closing their eyes for 3 seconds, which produces a 3-second algorithm signal our device detects. Paint mode allows the user to use imagined motor movements via the left and right hand and the left and right leg that produce mu and beta rhythms to direct the brush. Changing the direction of the brush can be done by simply changing the imagined motor movement or movements they do. However, if the user makes an error, imagining opposite limbed motor movements such as left hand and right hand movements simultaneously will undo the previous motor movement's corresponding action. Swapping back to color mode is done the same way by closing the eyes for 3 seconds. Here is a more in-depth breakdown of the imagined motor movement and their corresponding brush action. The right hand corresponds to painting in the right direction. The left hand corresponds to painting in the left direction. The right leg corresponds to painting in the upwards direction. The left leg corresponds to painting in the downwards direction. Combination of hand and leg movements also gives the option of painting in corresponding diagonal directions as seen here. However, as stated before, imagining opposite limb movements results in undoing the previous action, while 3 or more movements will produce no response.
Our device uses 13 total electrodes. The top 2 rows are used to identify imagined motor movements, as these areas lie on the primary motor cortex and frontal lobe. Specifically, C3, CZ, and C4 are used to identify imagined hand movements, while C1, C2, and CZ are used to identify imagined leg movements. P3, P4, and PZ are used to identify P300 signals, as they lie on the parietal lobe, and O1 and O2 are used to identify signals from closing the eyes, where the occipital lobe handles visual processing. To improve our EEG monitoring and identification, we will integrate a bandpass filter at 6 to 35 Hz, mainly to remove any artifacts while keeping the mu and beta rhythms that desynchronize during motor imagery. An improved EEG spatial resolution will also help the BCI discriminate between left and right motor imagery.
Safety and feasibility. The use of temper foam in our design is to keep the user comfortable due to its lightweight and soft padding, which helps reduce fatigue from long use. The Velcro straps make the device adjustable for the user's own comfort as well. The areas that contain holes for electrode insertion are made of rubber that stretch when inserting the electrodes, so they are secure in place as the rubber shrinks. The helmet-like design helps to keep the device attached to the person, with the clips holding the electrodes in place. Our use of clips on the device also help keep the electrodes attached and prevent the wires from interfering with the user. Aside from the positive, we've also identified a main disadvantage in the painting capabilities of the device are fairly limited in color and painting direction, and learning the commands for painting might be difficult to learn and most likely will take time for the user to remember. However, more color and painting directions would require more commands for the user to learn and retain, so a healthy balance is needed between the painting capabilities and imagine motor movement commands as to not overwhelm the user.